In this video, we're going to look at some applications of the linear equations that we talked about in the previous videos. So I'm going to start with a couple of number problems that we can practice on. So let's look at the first application. It says 14 less than 8 times a number is 2 more than 4 times the number. What is the number? Okay, so let's let n represent the number. And now read this first sentence here. It says that 14 less than 8 times a number. Okay, so that would be, since it says 14 less, you really need to say 8 times the number first. So that would be 8n. And then if you want 14 less than 8n, you would actually do 8n minus 14. So that's this part right here. And then where it says is, that's the same as an equal to. So that is equal to what? It's equal to 2 more than 4 times the number. So now on this one I could do 2 and then plus 4 times the number, but I like to do 4 times the number plus 2. So since the number is n, then this part would be 4 times n plus 2. So there's my equation. 8n minus 14 on the left has to equal 4n plus 2 on the right. Now, the first thing I'm going to do is I'm going to get all the numbers to the right. So the way I'm going to do that is I'm going to actually add 14 to the left so that it'll cancel. As you can see here, it'll cancel the negative 14. And then I also must add 14 to the right. And when I do that, I get 2 plus 14, which is 16. So I'll bring down the 4n. And then bring down the 16, so I get 4n plus 16. And then on the left, all I had left was the 8n. Now, I want to eliminate this 4n from the right-hand side. So what I can do is I can subtract 4n from the right-hand side. So if I take away 4n from the right-hand side, then that would cancel that 4n. And then, of course, if I took 4n away from the right-hand side, I also have to take 4n away from the left. So I get 8n minus 4n, which is 4n. So I end up getting 4n equals 16, which is n equals 4. Okay, so the number must be 4. Now you can check it real easy because you just have to say, okay, what is 14 less than 8 times 4? Well, 8 times 4 would be 32. And then if you subtract 14 from that, 32 minus 14, I believe that's 18. And then that should equal 2 more than 4 times the number. So if you do 4 times 4, you get 16. And then if you add 2 to that, you also get 18. So it does check. Now the other number problem here says that the sum of 3 consecutive integers is 108. What are the integers? Now to represent 3 consecutive integers, you can let your variable equal the smallest integer, and then let x plus add 1 to your variable to get the next integer, and then add 2 to the interval to the x to get the next integer. So, think of it, if this was, let's say x is 5. Well, if x is 5, then x plus 1 would be 6, 5 plus 1, and x plus 2 would be 7, so that would be 5, 6, 7. So that's actually how you represent 3 consecutive integers. Okay, so now what does it say about these 3 consecutive integers? It says if we sum those 3 integers, we get 108. So let me show you the sum. If I sum them, here's the first integer, and then x plus 1 is the second integer, and x plus 2 is the third integer. So notice I'm adding the 3 integers together, and then when you add, you get x plus x plus x, which is 3x. And then you get 1 plus 2, which is 3. And so you end up with 3x plus 3 equals 108. And now all you have to do is subtract 3 from both sides so that you can cancel this 3 right here. And then on the right-hand side, you get 108 minus 3, which is 105. And then so you got 3x left over here on the left. So 3x equals 105. So now all you have to do to solve for x is divide both sides by 3. So if I divide 3x by 3, I get x. And if I divide 105 by 3, you get 35. So now that's just the smallest integer. That's not all of them. So I have to go back to my expressions here. So if x is 35, that's the smallest one. Now remember, the next one is x plus 1, so what's 35 plus 1? 36, right? And then the next one is x plus 2, so what's 35 plus 2? 37. So your three integers are 35, 36, and 37. Okay, next we're going to do a couple of geometry problems. Kind of like the acorn that grew up and said geometry. Okay, all right, yeah, that was corny, I know. All right, so the perimeter of a rectangle is 150 centimeters. It says the length of the rectangle is 15 centimeters greater than the width. Find the dimensions. Okay, so what I'm going to do is I'm going to let W here be the width, and then the length, since the length is 15 more than the width, then if I add 15 to the width, that should represent the length. Now, if you remember the formula for the perimeter of a rectangle, the formula for the perimeter of a rectangle is that if you take 2W plus 2L, that equals the perimeter. Okay, so that's the perimeter formula. Well, I know 2W is just 2W, but for the 2L, I can actually replace the L with W plus 15 because I know the length is W plus 15. So instead of saying 2W plus 2L, I can say 2W plus 2 times W plus 15 equals the perimeter, and the perimeter up here is given as 150. So now if I simplify this, here I can distribute the 2 and I'll get 2W plus 30 here, and then when you add these two W's together, you'll get 4W plus 30, and then bring down the 150. And now I can solve the equation by just subtracting 30 from both sides. So take 30 away from both sides, and of course on the left hand side what it does is it cancels the 30, and then on the right hand side 150 minus 30 is 120. So I get 4W equals 120, and then to solve for W, just divide both sides by 4, and 4W divided by 4 is W. 120 divided by 4 is actually 30, and so the width is 30 centimeters, and the length is actually the width plus 15. So if you plug 30 in here for the width, you get 30 plus 15 is 45, and so that would be the length. So the length would be 45. All right, now we're going to do an age problem. Okay, so this one says a father is 4 times as old as his son, and then it says in 20 years the father will be twice as old as his son. Find the present age of each. Okay, so right now the father is 4 times the age of his son. So let's let x here equal the son's age, and then if the father is 4 times the son's age, then we can say 4x is the father's age. Now, let's increase their ages by 20 years. So if we increase the son's age by 20 years, we would get x plus 20. And if we increase the father's age by 20 years, we would get 4x plus 20. And now, remember, in 20 years, the father is twice as old as the son. So the father's age, here's the father's age, 4x plus 20, and that has to be equal twice the son's age. So 2 times x plus 20. And then if you distribute the 2, you get 2x plus 40 on the right-hand side. So now we play our game, subtract 20 away from both sides so that the 20s cancel over here, and then over here 40 minus 20 is 20. So I get 2x plus 20 on the right-hand side, and then I just have 4x on the left. And then to get rid of the 2x from the right-hand side, I need to subtract 2x right here, so that when I do 2x minus 2x, it cancels and I just get 20. And then on the left-hand side, I take 2x away to the left-hand side because I took 2x away from the right-hand side. So 4x minus 2x is 2x. So I get 2 times x equals 20. And I figure you can do that in your head. Just divide both sides by 2 and you get x equals 10. So the son's current age is 10, and the father's current age would be 4 times that, which is 40. Remember, the father's current age was 4 times x. So take 4 times 10 and you'll get 40 for the father's age. And by the way, if you add 20 years to each of their ages, if you add 20 to 40, you get 60. If you add 20 to 10, you get 30. And certainly enough, 60 is twice the age of 30. So it does work out. Okay, now this one is a distance, rate, time problem. A man walks at the rate of 4 miles per hour. How far can he walk into the country and ride back on a trolley that travels at the rate of 20 miles per hour if he must be back home 3 hours from the time he started? Okay, so I want you to remember that distance is actually equal to rate times time, which means that time is distance divided by rate. Okay, so let me show you why I need that. Okay, so basically the father's going to walk one way and then ride back the other way. So we want the time it takes him to walk. So the time it takes him to walk is the distance he walks, which we don't know. That's the unknown. So the distance he walks divided by the rate he walks. So the time that he walks into the country is the distance he walks divided by the rate he walks, which is 4. And then the time it takes him to get back is the distance he travels back divided by the rate he travels back, which is 20. And since the total time must be 3 hours, if we add this time, which is distance over 4, to this time, distance over 20, that should equal 3. And you can see that's what I have. Distance over 4 plus distance over 20 is 3. And again, the distance over 4 is the time it took him to walk into the country, and the distance over 20 is the time it took him to come back on the trolley. So now those two distances should equal 3 hours. Now to solve this, remember earlier we had to multiply by the least common denominator. So the least common denominator of 4 and 20 would be 20. So if I multiply 20 by d over 4, then I know 4 goes into 20 5 times, so that's just going to give me 5d. And then if you multiply 20 by d over 20, the 20's cancel and you just get d. And then 20 times 3 gives me 60. So I get 6d equals 60, and then if you divide both sides by 6, you get d equals 10 miles. So he can only go 10 miles if he wants to get back within 3 hours. Okay, one last problem here. I have a horse and a saddle. Total cost is $5,000. If the horse cost 4 times as much as the saddle, what was the cost of each? Well, since the horse is 4 times the saddle, then let's just let C be the cost of the saddle. Then 4C would be the cost of the horse. And then we know if we add the cost of the horse plus the cost of the saddle, that should equal $5,000. So 4C plus C would equal 5C. So 5C equals $5,000. And then divide both sides by 5, and you get C equals 1,000. So $1,000 for the saddle, and then the cost of the horse would be 4 times that number. So 4 times 1,000 would give you 4,000 for the cost of the horse. And so there's several application problems on these linear equations.